Hi everyone. So in this video I wanted to walk through a number of the examples in chapter 3. You'll see the ones that I'm going to go through listed here toward the bottom of this notepad document. In the top half you'll see a good number of the methods that are covered in those examples as well as a few others. And my hope is that by the end of this video we have taken a look at every single thing inside that notepad document. And right here I would say is pretty much everything that you've learned so far in processing. So slowly but surely, when you think about the reference page that exists for the language, which is far longer than what I had highlighted here. As the semester goes, you will slowly but surely be able to put a check mark next to a growing number of these methods and properties and structures, and by doing that really know how this language works and be able to work with it creatively. We've already looked at a few of these methods: size, background, ellipse, fill, probably a couple of other ones here too. By the end of this video we'll have looked at all of these. And as you know, methods, which I've been calling kind of the verbs of a computer language, take parameters of information, sometimes also called arguments. These are the pieces of information that a method needs to know what to do. So for example, if I want to define the size of the display window that's going to pop up, I need to offer processing two pieces of information. In example 3-1, the two parameters that they put in are 800, 600. The order in which you put information inside the parentheses is totally defined, so that's important too. The order basically lets processing know which piece of information goes with which part of the hidden code that it runs to do the thing that this method does, which in this case is to draw the display window. So 800 defines the X or horizontal width of the display window, and the 600 defines the Y or vertical height of the display window. When I click run here, let me quickly show you this. The window that I'm working with is 1920 by 1200 pixels, 1920 across, 1200 down. So 800 by 600 is less than half of the entire resolution that I have to play with. Let me hit run. Certainly less than half. That is an 800 by 600 display window. And all example 3-1 is trying to do is just trying to acclimate you and kind of get you comfortable with and used to working with that kind of a method. Obviously it's an important one. Now so far we've been creating sketch windows that are almost squarish or look like rectangles that are close to squared. But you can create display windows in all different kinds of rectangular shapes. For example, the following display window is going to be 200 pixels across and 800 pixels down. That can be the display window for a sketch that you create. Or I could do the opposite here. I know that the resolution of my screen is 1920. So I could create a window that is the entire length of my screen, but only 200 pixels down. You can't make triangles, you can't make, quadrilaterals. It has to be rectangular or square, but you've got a lot of freedom with how you define the size, the width, and the height of your display windows. Now, something that doesn't get mentioned in example 3-1, but I just wanted to bring it up again here, which is the background. Background lets you define the background color or shade of your display window. So let me go ahead and switch this to a more reasonable size. There are a number of different parameter sets that you can put into background. I can offer it just one hexadecimal value. For example, hashtag FFFFFF, which is the color white. For any of you who've worked in HTML or CSS, you're probably familiar with the hex values that define RGB color. So background here, and we get a white background. If alternatively I type in 000000, then the background is black. And you've got access to all those different colors on the red, green, blue spectrum by using this one parameter, the hexadecimal. What I can also do, as we've been doing, is put a number from 0 to 255, which represents one of the 256 shades of gray. So if I just give it one parameter and it's an integer value within that range, processing knows that I'm trying to set a grayscale value. So for example, if I put in 255, we get a white background. That's the equivalent of the 6 Fs that we saw. And if I put in 0, we get black. You can also pass it 3 parameters, which would represent red, green, and blue colors, which when combined create a specific color. So for example, if I go to color selector and select this green right here, I could put in this hexadecimal value right into background, or I can put in these 3 integer values which represent the red, green, and blue shades that combined create this color green. So let's do that. 56, 206, 100. I'm going to close that out. I'm going to run this, and there we go. Now Newport is going to go into a lot more about color, so all I really wanted to do is just explain to you a little bit more about parameters. I'm going to set this right now to 155, which is a grayish color, and move on to the next thing. Now what I want to do is kind of digress for a minute to bring up a method that isn't talked about in chapter 3, but it is so important, especially as we move forward with interactive sketches. You're going to be using this println method all the time. Let me go ahead and type in println. And inside println, I have put a statement in quotes. And I'll run this. The display window opens up. Nothing is in the display window, but in the message console down here, we get the text that I printed. Okay? The message console is a place where you can pass values or information from a sketch that is running or which you run to better understand some of what your code is doing. I mean, there's a lot of different things that go on in the message console, but I think that's one of the basic ones. When we actually start developing interactive sketches and things aren't working and you want to chase down the value of a particular variable to understand why things aren't working, or if you just need information from the system as it's running, for example, what's the position of the mouse on the screen, you can use println to basically publish that kind of information to this message console. It won't show up in your display window. Your users of a sketch won't see it. You could think of it almost like hidden comments. The reason I'm bringing it up now is because there are two properties listed here. Everything that we've been learning so far is basically a method, so it ends with an open and closing parentheses and then a semicolon. Properties are kind of like the nouns of processing, and they hold specific values in them. And width and height are two properties that hold the values of the width and the height of the display window. So I just wanted to show this to you really quickly. If I type width comma height inside the parentheses of println and hit run, nothing shows up in the display window, but down here in the message console I get 800, 800, and I get 600, 600. So I don't know that we'll use println again in this video, but I wanted to finally introduce it to you, and along with it, the first two properties that you have access to in processing. Now there are far more methods than built-in properties in this language, but when we get to variables, excuse me, the variables that you create are basically properties, and println is going to become incredibly useful. Alright, so we've got our size and we've got our background. Let's take a look at example 3-2 in chapter 3, and that is all about the point. As you learn each one of these different, as you learn how to work with things like the point and all the different shapes, what you need to learn are the different parameters that it requires. So take a look at what shows up here in the error box, because processing is basically telling you, hey, you're not done writing this, it's not working, it's not going to work. And it tries to help you know what you need to give it. So point requires two values. And as you might imagine, the values are going to be the x and the y values that define the position of that point within the display window. The display window is 800 pixels across and 600 down. Let's put a point directly in the middle of that. 400, 300. I'm going to run this sketch, and the point is going to be tiny, but I hope we can see it. Barely. There it is right there. Let's see if we can make that a little bit more visible. 255 is the color white. It still looks almost like a speck of dust. I mean, it's just that small. But that is the point. So let's move on to the next example here. 3-3, and that is to draw a line. Now, lines require two pairs of values. The point only needs one x and one y. Well, the line needs two x's and two y's. It basically needs to know the starting point and the ending point for the line. Once you give it the beginning and the end points, it'll draw the line between them. So again, we know our display window is 800 by 600. Let's have a line that goes straight across horizontally, splitting the display screen in half. So I'm going to put 0, 300, comma 800, comma 300. Let's just think about this for a second. 0, comma 300. So along the x-axis that begins on the left and counts up toward the right, 0 all the way up to 800. 0 is all the way flush on the left side of the screen. And then along the y-axis, which is 600 pixels in height, 0 is at the top, and it goes all the way down to 600 when it gets to the bottom. So along the y-axis, 300 is right in the middle of the screen. So 0, comma 300 is right here, and then 800 along the x-axis, comma 300 is all the way here. So I've basically just given it this point and that point, and then processing draws the line between it. Let's try another example. I want to draw a line from the top left to the bottom right. And this is a good example to try out because it also just reinforces the way the display windows width and height work numerically. So if I want to start in the top left corner, that is going to be 0, comma 0. So I'll type that in. And if I want to go all the way to the bottom here, that's going to be 800, comma 600. There you go. And if I wanted to do a line from here all the way in the top right corner to the bottom left corner, let's think about that for a second. What would it take? .800 pixels across would put you here on the x-axis. We haven't gone anywhere along the y-axis, so that's going to be 0. And then to get down here, we're back to 0 on the x-axis, but we're at the very bottom of the y. So I stop that and I run it. There we go. All right, let's move on to 3-4. And for this, I'm going to pause the video just long enough to write down the 3 lines of code there for the quad and the 2 triangles. All right, so let's take a look at this sketch here. This is 3-4, draw basic shapes. There is a quadrilateral and 2 triangles. And as is explained on the page preceding those examples, for a triangle, you need to give it 6 parameters. If you want to draw a triangle, you need to pass 6 parameters or arguments in the parentheses, and they represent 3 pairs of XY points. And a quad, since it's 4 corners or 4 points, you have to pass it 8. And especially when I look at the quad, but also the triangle, I wanted to bring up a point here about readability. The way your code looks in this text editor, I mean, once you get past the requirements of how code needs to be written for processing to read it properly, for example, having the semicolon here, having the comma separating each of the parameters, you can format your code, indenting it and whatnot, really for your own readability. So let me give you an example of what I mean by that. Right now, to me, this is just pretty complicated. I mean, it's really just kind of like a number sausage. I had a friend's social scientist who, in whose scholarship, putting 3, 5, 6 names of scholars into a single parenthetical citation was pretty common. You would call those citation sausages. To me, this is just a big number sausage, just a whole bunch of numbers, and it's hard to read it initially. So to make it more readable, I could indent and then put on separate lines each of the pairs of XY values. You're allowed to do that. Here, I'll do that with a triangle too, with one of them at least. Indent. And it just becomes more readable. Now I can see that the quad here has 4 pairs of numbers. I know that each pair represents the X followed by the Y position of a corner. And I can see how I've progressively kind of created that quad, or how I'm asking processing to draw the lines from one to the next comprising that quad, and likewise with the triangle. Let's run this sketch. It runs just fine with these indentations, and this is what you're looking at. So the quad is in the middle, and you've got one triangle up here and one triangle down here. And if you're not sure which triangle belongs to which bit of code, well, you can kind of start to figure it out just by looking at how low or high the numbers are. So for example, if I look at the y-axis, these numbers are higher than the y-axis here. This one, the y-axis value is 9. That's going to be really close to the top of the display window. And since it's the lowest number, which makes it the highest point in the display window, I'm going to assume that this triangle is this triangle. And this triangle is this triangle. Let's see if I'm right. And to see if I'm right, I'm going to bring up something that is at the very end of this chapter. Something called comments. Newport had some in some of what she was doing on Wednesday. I'm going to hit the / key, which is the same key as the question mark. And if I put 2 / before a line of code, you see how the line of code now becomes grayed out. That means that it's no longer a part of what processing executes when it runs a sketch. It's kind of like deleting a line of code without actually deleting it. You're just kind of making it not workable. So let me stop this sketch and run it again. And yeah, that second triangle there has disappeared. When I uncomment that line of code, the triangle reappears. And if you're thinking, you know, that display window is really big, I think I need to make it a little bit smaller. Well, let's think about how small we'd want it. This point here is probably this point here. So let's change our display window to 130. Yep, now the vertical height of our display window is fairly proportional to what the sketch offers. Let's do the same thing with the width of it. Looks like we've probably got at least 100 pixels here. But let's look at the quad and think about which x value is the lowest. And all the x values are now conveniently located in this first column. And the lowest one is 158. So we can assume that 158 is this corner of the quad. So it's 158 pixels of white space from the beginning of the display window to that point. So let's basically put 158 on the other side too and make things kind of even. So this point is going to be the farthest, the biggest x value. Now that's 392. So what is 392 plus 158? Let's find out. 550. You see how I just used the print line as a convenient calculator? I'm going to delete that line and I'm going to put 550 in here. There we go. A display window that looks a bit more proportional to the sketch in it. Okay, a quick pause, and I've deleted the code from example 3-4, and I've returned our display window to a size of 800 by 600 with a background color of 255, which is white. And what I want to do now is look at example 3-5 and then 3-6. Now we've already worked with ellipses, so let's even start with example 3-6. If I want to draw an ellipse, I need to give processing 4 parameters of information. The first 2 are the XY position of the center of the ellipse. The last 2 are its width and height. So let's put an ellipse right in the middle of this display window, and you guys were just doing this last class, so this should not be too difficult. 400, 300, and let's make an ellipse that is just 100 pixels wide and 100 pixels tall. So it's a circle. Now, all I'm really seeing is the black border around that ellipse because the white fill by default has been rendered basically invisible by the white background. That border, by the way, the key term for it is stroke. So I'm pretty sure we've worked with fill before. So I hope this isn't a complete surprise, but let's work with fill here to change the inside color so that the ellipse really shows up a little bit more than just as a circular line. I'm going to go ahead and put in a fill color. That looks interesting. And I'll put in the hex value just to save me a few keystrokes. I'm going to hit stop and run. There you go. We get an ellipse with that color purple at this position on the screen with this width and height. Let's do another ellipse and let's choose a different color for it. Okay, first of all, let's go ahead and draw it. Let's put it a little bit off center. So I'm going to do let's do 450, comma 300, comma 100, comma 100. So it's going to be the exact same width and height as the first one, and it's going to be centered exactly at the same point on the y-axis, but on the x-axis it's going to be offset by 50 pixels. And since 450 is bigger than 400, we know that that's moving it to the right since the numbers grow 0 to 800. Let me go ahead and play that or run it. All right. But I want to change the color of that ellipse. how would I do that? I simply put in another fill method right before the second ellipse. This first fill will impact any and all shapes after it. So if I had these two ellipses and a rectangle and a quad and a triangle, all of them would have the same color fill. If I want to have more than one shape on the screen and each of them has a different fill, then I need to put in a new fill method before each one of those shapes. So here, let's pick another color, and let's go grayscale here. There we go. And I'll tell you what, let's jump ahead to example 3-9, control your drawing order. I'd mentioned this in class the other day, but just to make it clear again, the order of your code is going to define which thing shows up in front of another thing on the screen. So, as I had said, when you put code, the earlier your code, the farther back your shape. Okay, so this ellipse is going to be behind this one. So let's flip this around so you can really see how that works. Now when I flip the order, you'll see that the gray one is behind the purple one. Okay? So the order of your code, basically as your code goes down the text editor, the shapes go on top of the ones preceding them. Okay, I deleted some stuff, and now I'm looking at example 3-5, which is draw a rectangle. Drawing rectangles is a lot like drawing an ellipse. You basically give the XY position of the center point for the rectangle, and then you give its width and its height. Let's go ahead and do that. And let's put this rect right in the center of the screen. 400, 300. And then let's make it 200 by 300. So it's going to be 200 pixels wide, 300 pixels tall. And why is that happening? Well, let's think about it. The XY position is 400 by 300. Ah, this is interesting. The ellipse by default has the XY position at the center point of the ellipse, but the rectangle's default is top left corner. So that can lead to issues like if you want to have a rectangle always drawn from its center point, do you have to figure out the math quickly in order to make that happen, or do you have to, as we get farther into the class, like write a function that does that math for you? Well, no, because it turns out there's something called rectMode, which will let you redefine the center point or the point from which a shape like rectangle is drawn. Let's just make sure this works. Yeah. So now the rectangle, the center point is 400 by 300, which puts us right in the middle of the screen, and it is 200 pixels across, and it is 300 pixels down. Without rectMode, that rectangle starts to be drawn from the center point of the screen, 400 by 300, and then it gets drawn 200 pixels across, 300 pixels down. So rectMode, which has several modes, let's take a look at them in the reference, lets you define the point from which the shape is drawn. You can define it by the corner, by corners, by radius, and center. Okay. Corners interprets the first two parameters of rect as the location of one corner, and the third and fourth as the location of the opposite corner. I'm not sure what that means. Let's take a look at what happens on the screen. Okay, right now, our rect is right in the middle of things. All right, that's pretty weird. Maybe we'll talk about that on Wednesday, because for this video, I'm not sure what to say without pausing and getting into stuff that's a little beyond chapter 3. But that's interesting. And let's take a look at corner. So the default rect mode for rectangles is corner. But if you want your rectangles drawn from the center of them, then you change the rect mode to center. For what it's worth, let's go ahead and work with an ellipse here. I'm going to put an ellipse again right in the middle of the screen. The ellipse mode by default is the center. But as with the rectangle, you have a couple of different modes to work with. Radius, center is the default, corner, and corners. Let's take a look at ellipse mode radius. Not sure if that's going to show much of a difference. Well, it's bigger. That's interesting. All right, and let's take a look at corner. Yep, it's off center. You can kind of tell it's basically drawing it as if it's inside of a rectangle. It's drawing it from the top left corner of the overall size of the implied rectangular container. All right. Well, enough with that. Okay, I think I'm getting close to the end of this video. Just want to go through a couple more things. Let's take a look at strokeWeight, which is example 3-11. And I don't have that listed up here, so let me go ahead and put that in there. strokeWeight will define the thickness of the stroke or border around the shapes that you've been working with or I've been working with, like the ellipse. By default, the stroke is 1 pixel in width, but things can change radically as you raise that number. So for example, if we put in a strokeWeight of 40, let me stop this sketch and run it again. That starts to look like a really different kind of shape, really, or a different kind of ellipse drawing. The same thing would work with a rectangle. So if I put in rectMode center, just so I don't have to do the math on the fly here, and I know it's going to be at the center of the screen, and put in a rect of 400, 300, and let's do a square this time, 300 by 300. That strokeWeight, that is exactly 40 pixels in thickness or width or weight. So I think that pretty much ends this video. It's a little bit long. I hope you stuck with me all the way to the end. We actually did every single thing, I believe, that's in here. Size and background, print line, width, height, point, line, triangle, rect, quad, ellipse, yep. Fill, stroke, strokeWeight. noFill and noStroke we didn't go over. We did go over rectMode and ellipseMode. With noFill and noStroke, you don't put any parameters in. If I were to type in noStroke, then there's no border around the rectangle. And unfortunately, since that rectangle is by default with a white fill, it just doesn't even show up. How can I change that? If I change the background color, there's the rect. All right. And if I comment out noStroke and put in noFill, I hope you can imagine what's going to happen is we'll be back with that border, but nothing on the inside. Same color as the background. And then we can have some fun here with strokeWeight. I'm just going to get a little bit crazy here. The fill is, there's no fill, so it's the same color as the background, but now you're starting to have some fun with stroke and with shapes and drawing. All right, thanks everyone. That is it.